So in my second post that I did today, I explained that you could effectively store all the files and the kpse which command, all that data, you could store that in Git. And instead of doing kpse which to find the file, you'd say year engine file, because that's what the kpse depends on anyway. And it would find that in this big unified tree. So it would be possible to incrementally build a Git repository that just stored a big tree, and it had a top level directory for every year. And then it would have, for every year, it would have the engines, and for every engine, it would have the names of the files. It would just find things, and it should give the same results as kpse which. So I see that as a solution to multiple problems. The one is storing the data, and the other is getting the data. I'll say a few words about something I'll post tomorrow, which is using it with the existing executables, because that's going to be an important issue for some time. And actually, all the technology for doing that, I believe, already exists. Ubuntu is at least on Linux, Ubuntu has developed something called Snap as a way of distributing applications. And there's some duplication in that they don't rely on their own shared libraries. They carry their shared libraries with them. So it's a sort of packaging that avoids what is in Microsoft world called DLL. And that is based upon what's called the Squash file system, which is a compressed file system used for devices such as routers. So it's a read-only file system and you can mount it. And a Snap is a Squash file system mounted in a particular way with additional features that provide the executable applications having the right policies and so forth. Well, we're just interested in providing a tree, and we'll keep the executables out of the tree if you don't mind. Well, probably. So if we build not a Git file system using Git packs, but a Squash file system, maybe we will put the executables in it, but if we just build a Squash file system, then that's something that can be basically dropped into place and then it just runs. And that's the big advantage of Snap applications, is you just drop them in place and they run, and there's no configuration. It's just copy and run. And there's, until uninstalling, you just delete them. So the whole installation and deinstallation process is reversible. And assuming Snap file systems allow the same data to manifest itself in several places, which is something I haven't checked, one could create a Snap file system that contains all the macros, all the style files for all the tech lives, I believe, from the beginning to now, and I don't suppose it'll be more than a few gigabytes. It won't be possible to extend this in the same way as you extend the Git file system. But if you wanted, for example, what I'm doing here is I'm describing a use case for which Snap file system is fairly optimal. And that is, you want to use a quick to start, quick to finish web service, such as provided by AWS Lambda, where you've got about 50 megabytes to play with. So the idea is you just get the resources you need for the typesetting for the documents you've got, put it into the Squash file system, and then AWS Lambda, when it's invoked, will get that Squash file system, copy it over as a lump. There's no moving this file here, moving this file here, moving this file here. It's just move the whole blob over, mount it, and then it's got everything it needs to do the job. And at the end of that, it gets thrown away. So that sort of application is something where a Squash file system would work well. But otherwise, to use things with the existing architecture will be a bit more hard work, and I don't think it's that doable at present, except in a number of interesting special cases. So I think I'm going to stop at that point, because I think I've given an introduction to all of this. So I'm going to pause